Hello, I'm going to do these problems, both standard algorithm and conceptual understanding of the algorithm. So this first one I'm going to use some of the language that it does not make sense mathematically that we tend to want to teach the kids, but they don't know what's going on. They just, the words don't make really sense literally. So what we do is we say to the kids, 5 goes into 5. And I always make fun of gazinta. Like when someone sneezes, we say gazinta, and it sounds like gazinta. 5 goes into 5 one time. 1 times 5 is 5. So we put 5 here and we subtract. 5 minus 5 is 0. We always bring down the next number, 4. 5 does not go into 4, so we have a 0 here. 0 times 5 is 0. 4 minus 0 is 4. The next number we want to bring down is the 3, because it's what's left over. Or 4 is left over, and we bring down the 3, so we get 43. 5 goes into 43 8 times. 8 times 5 is 40. And we subtract, so we get 3, bring down the 5, and 5 goes into 35 7 times evenly, which is kind of funny. We say evenly, and it equally should probably be what we say. 7 times 5 is 35, and that leaves us with 0 remaining. 5 does not go into 0, so we're finished with our problem. So we have a remainder of 0. So the answer is 1087, remainder 0. Okay, now conceptually what's really happening is we know that division means partitioning, which also is like repeated subtraction. So we have a dividend, which is the amount of objects that we're given, and a divisor, which is a number of groups that we're going to partition the objects into. The quotient is the number of objects in each group, and we sometimes have a remainder. So I've drawn here 5 groups, and I could take 5,435 objects and start partitioning them one at a time, which would use up 5 objects. So I've written here the powers of 10. So I have 5 times 1 is 5, and then if I were to pass out 10 objects at a time, I would use up 50. 100 objects of 5 at a time would be 500. 1,000 objects of 5 at a time would be 5,000. As I go about doing this, it would take quite a bit of time to do it one at a time, so I would start to go with these higher powers. What 5,435 divided by 5 really represents 5,400s, 3 10s, and 5 1s divided by 5. So I'm going to go over here and I'm going to say, okay, well, I'm in thousands here. If I check my thousand partition to 5 groups, it uses up 5,000. So I could say that 1,000 out would take out 5,000 of this object. Oops, sorry, 5,000 objects right away. So 5 minus 0 leaves us with 5, 3 tens, 4 hundreds, and now we have 0 thousands. So then the next thing we look at is, okay, I'm in the 400 spot. If I go here, right now I have 435. If I go here to my pass out 100 at a time to 5 groups, it's going to use up 500. 435 is less than 500, so we can't pass out 100 at a time. So I'm going to say we can't do 100 at a time. I'm going to say 0, 0, 0. So let's see, we have 1 here and we have 0 here. And we're going to subtract out 0, which leaves us again with 4, 3, 5. Now I'm looking at, let's go to the tens. If we were to pass out 10 at a time, we would use up 50. I have 43 tens and 5 ones. So if I want to pass out to 50 at a time to 435, I would do 80, I guess it's 80 times 5, which would be 400. Subtract this out, I get 35. So I look up here, 50 is too much, so I can't do another 10 objects. I have to go to my ones. So if I pass out one object 5 at a time, I'll get 5. But I know that if I do that 7 objects at a time, 7 times 5 is 35. That's a nice number for me because that's what this is. Subtract that out, I have 0 left. So when I get to 0, I know I've completely passed out all these objects equally. So I have 1087 with a remainder of 0. So that's what's happening conceptually. So then let's look at the other problem, see if I can do this here. I got it all set up for us, so let's do this the wrong way. No, it's not wrong, but it's just weird. Okay, I have 12 does not go into 3, so we put a 0 above here. 0 times 12 is 0. I get 342 left. 12 goes into 342 2 times, which is 240. Which leaves us with 102. 12 goes into 102 8 times. 8 times 12 is 96. We're going to borrow 10, 9, bring over 10, 12 minus 6 is 6, and 9 minus 9 is 0. 12 does not go into 6, so we have a remainder of 6. So the answer is 28, remainder 6. Now let's do this conceptually, making sense. Division is partitioning, which is repeated subtraction. I have a dividend, which is a number of items divided into a number of groups, is equal to the number of items in each group with a remainder at times. So I know that 12 times 1 is 12, 12 times 10 is 120, 12 times 100 equals 1200, and that's nice for us to work with these zeros because this represents 300, 4 tens, and 2 ones. So I'm going to go over here and I'm going to say, okay, we have 3, we're at 100, so I'm going to check my hundreds. Oh, 12 times 100 is going to be way too high. It's going to be 1200, so I can't even use 100. So I'm going to put a 0 above the 100. 0 hundreds. Okay, then I'm going to do, let's do 10 at a time. We still have 342 left. So if I pass out two objects at a time to 12 groups, or sorry, it's 20. 20 objects at a time to 12 groups, it's going to be 240, and I can do that. So 240. 102. And so then I can say, okay, can I do another 120? I can't do that, so I'm going to go past the tens and move on to just one object at a time. It's going to take me a long time because I want to pass 102 objects. And so I'm going to say if I pass out 8 at a time to 12 groups, it's going to use up 96. So we have 8 times 12 is 96. That leaves me with, let's see, 6 remaining. So I have 28 with a remainder of 6. Same answer that we got up here. So that's how it works conceptually. I think we need to be careful when we look at words that don't make sense because it's like another language that just doesn't make sense if you don't know what you're talking about. So they need to understand what's going on conceptually so that they can see what's happening. So that's how I do it. Thanks.